Alright, this section is section 1.6 from Algebra 2. We are going to solve linear inequalities. First thing we need to talk about is how we're going to graph inequalities, and we need to remember the key things that we need to know about graphing inequalities. Remember, when it's greater than, equal to, those are the two. So again, if it's greater than, or if it's greater than or it's less than, then we need to have open dots on there because it cannot be equal to. If it's greater than or equal to or less than or equal to, then we are going to have closed dots because it can actually equal that point. So let me show you what I mean. So if we graph the first one, the first inequality is x is greater than negative 3. Well, first thing we need to do is we need to go to negative 3. And some people like to draw their dot right on the graph. I like to do mine above it. And I'm making it an open dot because notice that that is not an or equal to sign on there. So it's going to be an open dot because I can actually equal that negative 3. Now I'm going to need to have the numbers that are x is greater than negative 3. So I always like to put a test point in there. The easiest test point for me is 0. Is 0 greater than negative 3? Well, yeah, it is. I'd rather have no dollars than owe $3. So that means I'm going to shade that direction, and that arrow goes there. We're done. Easy peasy. Now let's go graph x is less than or equal to 0. Less than or equal to. That or equal to tells you at 0, I need a closed dot. Now I got to think about which way do I go, left or right, to go less than. Well, I'm going to go that way, right? And since these ones are so simple, I'm just going to do this next one. It is a little bit trickier because negative 2 is greater than x. So we know we need to go to negative 2. We also know we need to have an open dot. And what I like to do personally, I like to flip-flop these. So I'm going to flip-flop them. And I'm going to have x. And notice that that arrow to my inequality is pointing at the x. So I'm going to make it point back at the x again, negative 2. Same exact thing, just read a little bit differently. Instead of negative 2 is greater than x, I have x is less than negative 2. So now we go back, and we can go back to either way we want to do it. We need to find numbers that are less than negative 2. So we know negative 3 this direction is. So again, negative 3 is less than negative 2, or negative 2 is greater than x, or sorry, negative 3 if you do not flip-flop it. That's okay. All right, there is a catch to when we actually solve inequalities. Usually we're solving it just like we're solving regular equations. But if we multiply or divide by a negative, we have to flip the inequality. And really just the inequality symbol. Sorry for my handwriting if it's hard to read, and not sybil, but symbol. Okay, so that might be kind of hard to understand, but let me show you. So if we solve for negative 4x is less than or equal to 20. Well, to solve this, really, we just divide by negative 4, divide by negative 4. Now, if you look at that, well, those cancel out. We're left with x and negative 5. But since we divided by that negative number, instead of having less than or equal to, we're going to change it to greater than or equal to. And so then we're going to go to our graph, 0, negative 5, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2. And we're going to have a closed dot because it's or equal to. Now x is greater than, so we know we're going to shade this way. All right, let's try this next example where it's x divided by 2 is greater than negative 10. Now to get rid of that 2, we're going to multiply by 2. So I'm going to multiply this negative 10 by 2. We're going to get x and we're going to get negative 20. Now here's the catch. Did I multiply both sides by a negative number? No. I didn't multiply both sides by a negative number. I multiplied it by just a positive 2. So even though that is a negative, I didn't multiply by negative on both sides, so my symbol stays the same. So I'm going to put 0, negative 20, and on this side I'm going to put 20. I don't need to do every single dot on there to prove that I can graph it. I'm going to put an open dot at negative 20 because x is greater than negative 20. And then I'm going to draw my arrow to the greater section, the numbers that are larger than negative 20. All right, let's try to solve another one here. So this is multiple steps, just like when we're solving equations. So if it helps, forget about this being that and just change it to equals. y over negative 3 plus 2. So now we're going to subtract 2, so we get negative 7 is equal to w divided by negative 3. Now here's the trick though. We are going to multiply both sides by negative 3. So we need to remember, okay, we multiplied by negative 3, so this sign needs to change. So, but either way, we're going to multiply by negative 3, so we get 21, and these cancel out, so we get w. Now we have to go back to our original inequality, bring it on down. But since we multiplied by negative 3, we're going to flip it. And now again, I like to get my variable first, so I'm going to flip-flop these, and I'm going to make it w is less than 21. Now, do you have to do that? Absolutely not. That's the way I like to do it. 0, 21, negative 21. I'm going to have an open dot at that 21, and I'm going to shade to the left because it's less than. We have two variables here. Again, just like the equal sign, we need to get everything on one side. So first thing I'm going to do is I'm going to subtract the 4x. This is what I like to do personally first. You can do different steps here. It's not always the same thing. Again, we're going to bring that down. We haven't multiplied or divided by a negative number yet. I'm going to add 5 to both sides. So we get 8, and we get 2x. Again, we haven't multiplied or divided by a negative number. We're dividing by a positive number. So we get 4, and we get x. And since it's a positive number, again, they're going to stay the same. Again, I'm going to flip-flop this, and I'm going to make it x is greater than or equal to 4. You can probably do this without flip-flopping it. I understand that. Go ahead. I'm doing it this way because that's the way I like to do it, and I always like to have my variable first. Now we're going to have a closed dot at x, and since it's greater than, we're going to go to the right. All right. I'm going to let you guys try these ones here, and I'll put the answers up for you, and then you guys can check them. So I want you to pause right now and try them on your own. All right, if you guys got these answers, you guys will notice something weird. When you do the math on this one, you end up with 0 is greater than or equal to 12, or if you ended up flip-flopping, it ended up being 12 is less than or equal to 0. Now, is 0 ever greater than 12? If I have $0 and you have $12, will I ever have more money than you? No. So there's 0 solutions. There are no solutions for this problem because 0 can never ever be greater than 12. Similarly, for that last problem, you should end up with 30 is greater than or equal to 0. 0 is less than or equal to 30. Now, is that going to ever happen where it's not true? Well, it's always going to be, if I have $30 and you have $0, I will always have greater dollars than you, so that's infinite many solutions. Now, in this first problem here, you really could have stopped right here and realized, all right, I know negative 3 can never be greater than 9. And on that second solution, I could have always looked right there and been, okay, I know that 21 is always greater than or equal to negative 9 and stop. All right, now we need to talk about compound inequalities. What a compound inequality, it's when you consist of two simple inequalities joined by an and or an or. So if we look at this one, it's x is less than or equal to negative 2 or x is greater than 1. So I'm going to graph this so you guys can see what happens. So I'm going to graph this first one first. So x is less than negative or equal to negative 2, so it's or equal to, and it's less than, so it's going to the left. Or x is greater than 1, so I'm going to go to 1, and it's an open dot because it's greater than, and it's going that way. If you notice, they end up going opposite directions. That's an or statement. Now an and statement looks a little bit different because I don't even write and inside of there. But if you look at this, I'm going to graph it. I'm going to change this into two different pieces. So I'm going to look at this part first. And really, that is the same thing as x is greater than negative 1. You guys can see that I just flipped it around so the x came first. So now I'm going to graph that part there. And it's an open dot because it's greater than. And I'm just going to draw a little arrow going that way to start out with. Because now I'm going to look at that second piece where it's x is less than 2. Well, at 2, we're going that way. Well, if you look, those arrows, what's happening to them? They're going to meet each other. So really, the and is everything in between those two. So it's what connects those two to each other. So if I were to graph this in one fell swoop, it would be at negative 1, we're going greater than, and at 2, we're going less than. Connect them in, we're done. There's our graph. So if we look at these problems here, these should be easy peasy to tell if they're and or ors. Ends go together, ors go separate opposite ways. So if we look at that first one, we know we're going to start at -3. We know it's an end because they come together. It's going to be or equal to, put the x in the middle, and 2. This next one's a little bit trickier to write because they're going opposite ways. But we need to look. This one, x is getting smaller, so we know that x is less than, and it's not or equal to because it's not in there, so it's -3. Remember, or if there's a gap in between them, there's an or. If they're going opposite ways, it's an or. X is greater than 0. Now let's try some compound inequalities where we actually have to solve them first. So you guys can tell this is an or statement because it has the word, or it has the or written in there, and it's written as two separate inequalities. So I need to solve each inequality separately here. So first thing I need to do is -5 on this one, and we'll get 3x is less than or equal to 6, divide by 3, x is less than or equal to 2. That's our first piece. Now we need to solve the second inequality. So we're going to add 7. So we get 5x is greater than or equal to 30. Divide by 5. We get x is greater than or equal to 6. Now we need to put that or in between there. That's our inequality. Now let's graph this inequality. So I'm going to pull this over and I'm going to graph my inequality on my number line. So we need to go to where x is less, or so go to 2 first, so x is at 2. It's going to be a closed dot because it's or equal to, and it's less than, so it's going to go to the left. We also need to graph where x is greater than or equal to 6, so again it's or equal to, so it's a closed dot. Go to the right because it's greater than. Compound inequalities that are with the end are going to look different. They're going to look like one piece combined. Now with this one it gets a little bit trickier than the or, because whatever you do to one piece you have to do to all three pieces. So what I mean by is if we need to get this x by itself here, and you look, we have that pot or minus 10, so I need to get rid of that. I need to add 10. But since I'm doing it to that one, I have to do it to this one, and I also have to do it to this one. It'd be like breaking this up and solving it in two separate equations, or inequalities, but I'm going to solve it in one. So -4 plus 10 is 6, is less than 6x, because that cancels out, which is less than or equal to 24. Last step, I need to get the x by itself. I need to divide by 6. Remember, whatever I do to one, I have to do to all three. 6 divided by 6 is 1, is less than x, which is less than or equal to 4. There's our inequality. Again, graph it, and notice when it's in that and form where it's all graphed as one piece, they'll come together. So we know it's going to be an open dot at 1. It's going to be a closed dot at 4 because it's or equal to. Then we just connect them in. So again, open dot at 1, closed dot at 4, and because this one goes greater than and this one goes less than, bring them in together. All right, I'm going to do these special cases for you instead of having you do them like by yourself, or like I did before. So first thing we need to do is let's solve these. So we get x is less than 6, and we get -15, -3x is greater than -12, divide by -3. Remember, when we divide by a negative, we flip the sign, so x is less than 4. Now if we go to graph this, watch what happens when we graph this. We're going to end up with x is less than 6. So here's my 6. It's going to be an open dot, and we're going to go this way. Now when I graph my x is less than 4, we're going to go to 4, and again, we're going to go that way. So really, there's kind of a trick to doing this. We're going to combine those pieces, but if you notice, it can equal 4. So really, since it goes over the 4 on the left inequality, but doesn't equal it on the right inequality, it still equals it. So really, our whole graph is right there in that first inequality where x is less than 6. There's our graph. The next one, let's solve this one. So again, we're going to subtract 4 from every piece. So we get -1 is less than or equal to -x, which is less than -7. Now we need to divide by -1 And this is where the trick is going to get into play, because we're going to get 1, x, and 7, and we need to flip each sign. Flip each sign. So now if we were to graph this one, extend that, pull this out. If we were to graph this one, we're going to go to 7. We're going to go to where x is equal to 7, and it's going to be greater than 7. And we're going to go to where x is equal to 1, and it's going to be less than 1. If you notice, this makes it so it's a compound inequality, which means we really need to rewrite this where x is less than 1 or x is greater than or equal to 7. So this became a compound inequality. And by compound inequality, I do mean an or statement versus a... Alright, I'm only going to do one word problem for you guys, and I'm going to actually do it with you right now so you guys can see how to do it. You have budgeted $66 a month to spend on yoga classes. Your yoga studio charges $22 per month membership fee plus $5.50 per class attended in that month. Describe the possible number of classes you can attend each month. Well, it's kind of tricky on this one because they have a per month membership fee, but we're talking about in each month how much it's going to cost. You also have a $5.50 per class attended. So that's what we're going to use. And I'm going to use X is my number of classes attended. Okay, so I'm going to first start out by writing my expression for how much I'm going to pay per month. So I know it's going to cost me $5.50 per class attended plus $22 per month. Now I have to look at how much money I can spend. I can spend $66. I know that much. I can spend $66. But you notice, if I have a budget of $66, I don't have to spend $66. That's the most I can spend. I can be cheaper if I want to and save some money. So that means that my left side has to be less than or equal to $66 because I can actually spend that much money as well. So I'm going to change my 5.5 or 50 to 5.5 when I subtract this away. So we get 5.5x is less than or equal to 44. Now I need to divide by 5.5 on both sides, which is going to get me x is less than or equal to 8. Now what that tells you is that I can attend at most 8 yoga classes per month. I can attend 7, I can attend 6, I can attend 5, 4, 3, 2, 1, or 0. But at most, I can attend 8 yoga classes. Alright, that is all for this section, so make sure you rewatch anything you need to rewatch. Pause when you guys need to pause, and make sure you guys understand this material.